This lesson, we're going to talk about a little more detail on the radicals. Here is a few rules that it will be help you to go over these sections. The first one is having a index odd or even, right? So we call this as index. We're going to look at a different index. We've been looking at a square roots before, right? It looked like this, square roots, but we can have also cube roots. So your index can become 3, that we'll call cube roots. If your index become 5, that's called fifth roots, right? So when this number, index and power, is odd number, then your number is negative, then your solution become negative. But if index is even and power is even, then your solution have to be positive. The reason is because if we have, for example, if we have 3 negative, this gives you negative 27, right? But then if we have even negative, this is going to give you positive, right? So for that reason, if you're looking at this, you're going to have negative 3, 4. That will give you a positive number. And because you have 4 of the same number, you can bring it outside of the fourth root, which makes it positive 3. You're going to have 7 of negative 5. So when you multiply negative 5 7 times, it will be still negative value. And get rid of the 7 of that by the 7 index, you will still get the negative solutions, right? So that's the reason behind when index is odd, you will get negative solution when your value inside is negative. When index is even, you will get positive solutions even though the value inside of the radical is negative. Another thing it will help you, this section, is when you have a multiplication and divisions inside of the one roots, you should be able to separate it out. And going the other direction also. So going this direction is also same. Something you can do, right? And also if you have power first or power at the end, that will be exactly same thing. There is no certain orders that you need to use. So let's look at example 1. Example 1 is asking you to identify the value inside of the radical. We call that radicand. And index. What's index? This little power right there. So the radicand for the first one is going to be 98. And then index is going to be 5, right? B, the radicand is going to be negative 40. Index is going to be 3. Radicand is 29. Index is no number means 2 square roots, right? This one, 5x minus 4 is inside of the cube roots. Index is 3. Let's look at example 2. Find the value of each expression. Let's see if we can simplify those different radical, right? This is cube root. Cube root means that you have to have same 3 numbers to bring it outside of the cube roots. And we know that 8 is 2 times 2 times 2. So that become 2. 64. 64, we know that's 8 times 8. 2 same number inside of square roots, so that become 8. This cube root, you have to have 3 same numbers. And having a negative 64, we know that 4 times negative 4 times negative 4 will give you negative 64. So your simplest expression of that radical will be negative 4. This one is same as having fourth roots of 1 over fourth roots of 16. And fourth roots of 1 is just 1. Fourth roots of 16, we know that this is equals to 2 to the fourth exponent. So fourth roots and fourth power cancel out each other, will be 2, right? What about example 3? Example 3, we do the same thing. Let's see if we can reduce. We know that, power and index cancel out. Your solution will be 4. This one also same. Power and index cancel out. Your solution should be negative 4. Remember, because your index was odd number, right? So your solution should be negative in this case. This one, if you cancel out index 4th with power 4, your solution should be 2. What about this one? This 2 cancel out, but it was even, so your solution should be positive 2, not the negative, right? Don't forget about that chart that we went over it. Let's do a few more of simplifying. This one, this is square roots with square, so that cancels out, will be x. We know that 32 is equals to 2 to the 4th, so this 2 cancels out. Oh wait, hold on, that's going to be 2 to the 5th, right? So again, let me erase that, undo. 2 to the 5th. So it means that fourth roots of 1, 2, 3, 4, 5, 2, out of 5, 2, this 4 become 1, 2. So that will be out. Those 4 will be outside of the fourth root, but the one that didn't have the matching 4 have to stay inside, right? Let's try one more time with this example. This is cube roots. 16 is same as 2 times 2 times 2 times 2 is cube roots. So 3 matching will be out as 1, 2. So inside cube roots, you have only 2 remains, right? The one that didn't have matching. What about this one? This is cube roots. We know 8 is 2 times 2 times 2. So that can be out of the cube roots. This x, you have 4 of them. So out of 4, 3, bring it outside. The one that didn't have matching will stay inside. Right? What about this one? Negative 16, right? So inside of the cube root, negative 16 is negative 2 to the 4th exponent. So all 3 of the same can be out. So out of 4, 3 will be out. So you will have 1 negative 2 stay. No, it should be positive 2 stay. Right? And then you're going to have 3 out of 4, 3 out, and then 1 stay. out of 7, you're going to have 2 of 3, which is 6y will be out, and 1 stay. So easy way to figuring out when you're dividing 7 with 3, 3 goes into 7 twice and remainder of 1. So this 2 will be out and 1 didn't have matching, will stay. Or if you wanted to see it as picture, you have, that's going to be y, right? 7y, 1, 2, 3, 4, 5, 6, 7 out of 7. This become 1, this become 2. 1y, the other y makes it 2y here, right? And the one that didn't have 3 matching will stay inside. But then we don't want it to draw like this all the time. What about this exponent is large, right? It's easier to do divisions. When you divide, whatever that it fits will be outside. Remainder will be the one it's staying inside of the radical. So then let's look at the next one. What about this one? This one is going to be equals to, let's change to exponents, right? So we know 8 is 2 cubed, x the 5th, 27 is 3 cubed. Because you have all this cube with cube roots, you can bring it outside. 3 will be outside. And even x out of 5, 3 will out as 1. And 2 will stay inside, right? What about the larger one? We will set 32. 32 is, oh well, before I change to exponents, I guess I can reduce 32 over 16, right? So when 16 goes into 32 2 times. So when you reduce that, you end up getting 2. And then you have x to the 9s and x to the square. Bring it up. 9 minus 2. It becomes x to the 7th. And then y will be on the bottom because your 5th exponent on y is larger. So bring y down. It will be y to the 5 minus 1 because you're subtracting one of the y from the numerator. You're going to get y to the 4th exponent. Let's see if I can bring anything out. Look like my x will be out. Out of 7, only 4 out. So you should have 2x cubed staying. What about y to the 4th? That cancels out. All 4 comes out, right? So will be no radical on denominator. So that's how you can simplify it. Let's look at example 4. This time, using all that information, how to simplify radical. Let's say once we simplify it, if we can do addition, subtractions, right? And don't forget, when we're doing addition, subtractions, we have to have a same radical. For example, if we have square root of 2 plus square root of 2, this is going to be 2 square root of 2. Why? Because we're going to assume this is going to be the term. Because we have a like terms, we can combine the one that we have in front. Something like if you have a plus a, this is 2a, right? Because you have a 1 in front. Same thing. You have 1 in front of the square roots, so when you add those 1, it becomes 2. So again, in order to do addition subtractions, you have to have same index, same radical, right? So if you're looking at this first example, it looks like you cannot add or subtract because you do not have same radical as it is. But once we simplify them, we might have the same radical, right? So we will start by simplifying. Let's see, this is going to be 3 times 9, that's 3 times 3. So it look like 2 same matching come outside. And this one is going to be 2 times 6, that's 2 times 3, to bring it outside. So it look like all 3 terms will have square root of 3 once you simplify it, right? So then you can combine. So I'm going to write this to show you what I will have. I start with the 4 times same two number will be out, and 3 will stay, right? It's 3 that didn't have matching. And the next one, you had 8 times 2 square root of 3 plus square root of 3. You do multiplication before subtractions. So this first radical, you have 4 times 3, right? So you're going to get 12 square root of 3. The second radical is 2 times 8, which is 16. And this is just 1, right? Once you have all the same radicals, see, this is all same radical, you're going to add the coefficients or subtract, right? Look like you have 1 in front if you don't have any number. So that gives you 12 minus 16 plus 1. That's going to be negative 4 plus 1 will be negative 3. If you don't understand or you're not quite getting this, let's try one more. This one right here, we're looking at a cube root this time, right? So if we have a same 3, I'd be able to bring it up, right? And 27 is 3 cubed, right? So when I simplify this, I get 5 times 2. And this x to the 4th, I can bring 3 out and 1 will stay. So x and 1 stay. And this is going to be, I can bring the negative out. So I can have the same radical. And then plus 4 times 3 cube root of x remains. So if I wanted to explain a little bit better on the middle term right here, right? This is going to be same as cube root of negative 1 times cube root of x. And cube root of negative would become just negative, right? Times cube root of x. That's how it become negative, right? Negative 1 cube root of square root of x. When we do the multiplication, it becomes 10x cube root of x minus 1 cube root of x plus 12 cube root of x. Same term, so when we multiply, we could do 10x minus 1 plus 12. But then this 2 is a like term. This is not, right? The number with the variable is not the same term. So you cannot combine that one. So you will end up getting 10x and plus 11 to the cube root of x. Oh, I'm missing x right there. Or if you wanted to answer your solution without the parenthesis, distribute one term into the two terms. Either way will be okay. Either way of the solution is fine unless they ask you a certain style. Okay, so hopefully now you understand how to simplify radical, any radical, and add and subtract.